Hey there, space detectives. Go ahead and grab your imaginary space helmets and welcome to This Explainer. Today, we're going on a seriously wild ride. I'm your host, and I am so excited to guide you through our very own cosmic amusement park. That's right, we literally live on a giant, spinning, zooming ride out in space. And you know what? It's full of incredible secrets just waiting to be uncovered.
Now, think about this for a second. Have you ever looked out your window at bedtime and wondered, why does the sun just seem to pack up and disappear at night? I mean, where does it go? Does it just turn off like some giant light bulb in the sky? Oh, and here's an even crazier question for you. If our planet is constantly spinning in space, why aren't we all dizzy, stumbling around and falling over all the time? Why does the ground beneath your feet feel so incredibly still?
Well, to solve these mysteries, we've got to look pretty closely at our own home. Here it is, Earth. It's a beautiful, rocky planet absolutely covered in oceans of water. It's perfectly designed for living things like you and me. But the absolute most amazing thing about Earth is that it is never, ever sitting still. Ever since our whole solar system first formed billions of years ago, this big blue marble has been constantly in motion.
So, the very first movement we need to talk about is a spin. Imagine an invisible line poking straight through the top of the Earth at the North Pole, going all the way down through the center, and coming out at the bottom at the South Pole. We call this invisible line an axis. Earth spins round and round on this axis, exactly like a giant toy spinning top on a table.
Okay, let's dive into this because there are actually two completely different ways our planet moves. First up, we have rotation. That's the spinning on the axes we just talked about. It takes exactly 24 hours to do one full spin, and that right there is what gives us our day and our night. But while it rotates, the Earth is also doing a giant lap around the Sun. That journey is called an orbit. It takes a whole lot longer, about 365 days. And that massive trip is what gives us our changing seasons, from those hot summer days to chilly winter nights.
Let's focus on that daily rotation for a second. Did you know that right now, if you're standing near the middle of the Earth, the equator, you are zooming around at over 1,600 kilometers per hour? That is literally faster than most airplanes fly. It's an absolutely mind-blowing speed. Which brings us right back to our big question. If we're rocketing around that fast, why on earth don't we feel it? Well, imagine you're riding in a super fast, perfectly smooth car on the highway. You're just cruising along, reading a book, or maybe playing a game in the back seat. If you close your eyes, you don't even feel like you're moving, right?
So here is the secret. Earth is the ultimate smooth ride. There are no bumps, no brakes, and no jolts. Because everything on Earth, the oceans, the mountains, the air, the buildings, and even you are all moving together at the exact same constant speed, it feels like we aren't moving at all. We really only know we're spinning because we can watch the sun, moon, and stars appear to glide across the sky.
Right. So how does all this spinning build our calendar? Remember how we said the Earth's orbit around the sun takes about 365 days? Well, actually, scratch that. It takes exactly 365.25 days. That means 1 year is 365 days plus a quarter of a day.
Now, we can't exactly have a calendar with a quarter of a day on it. I mean, imagine going to sleep at 6 p.m. just because the year suddenly ended. No way. So humans invented a brilliant math puzzle called the leap year. Every year, we basically save up that extra 0.25 day. After 4 years, those 4 quarters add up to one whole extra day. Boom. We stick it at the very end of February, giving that month 29 days instead of 28. Talk about perfect cosmic timing.
Okay, let's look out the window of our cosmic amusement park ride to our closest neighbor. That right there is Earth's only moon. It's our trusty travel buddy, covered in craters, spinning through space right alongside us.
But here is a super cool secret about the moon. It doesn't actually glow. The moon is really just a dark piece of rock. It doesn't make any of its own light at all. And this brilliantly illustrates what's really happening. The moon acts like a giant rocky space mirror. The bright glow you see at night is actually light from the sun bouncing right off the moon's surface and shining all the way down onto Earth.
Which leads us to a really fun puzzle. If the moon is the big star of the night sky, why do we sometimes look up, maybe while playing at recess or eating lunch, in the bright sunshine and see the moon just hanging out right there in the daytime sky?
Well, the mystery is solved when you realize the moon actually spends almost as much time in our daytime sky as it does in the nighttime sky. We usually associate it with the night just because that's when it stands out the most against the dark. But the moon is so big and it reflects so much sunlight that it's bright enough to shine right through the blue daytime sky, as long as it happens to be in the right position as we spin.
Now, what's really interesting about this slide is that the Earth doesn't always spin at the exact same speed. It's actually changing. Things like moving oceans, shifting air, and even melting ice at the North and South poles change the shape and weight of the Earth, which can make it spin just a tiny fraction faster or slower. But the biggest factor? It's actually our friend, the moon. See, the moon has gravity, an invisible pulling force. As the Earth spins, the moon's gravity grabs onto our oceans, pulling on them. This acts like a very, very gentle brake on our cosmic ride. Because of the moon pulling on us, the Earth's spin is actually slowing down. Now, don't panic, it's super slow. A day today is only 1.7 milliseconds longer than it was 100 years ago. So yeah, you definitely don't have enough time for an extra nap.
But speaking of time, this whole spinning thing creates a really confusing problem for us humans. If the Earth is a spinning ball, the sun is only shining on one side at a time. So, when it's bright morning for you, it's the middle of the dark night for kids on the exact opposite side of the world. So how on earth, literally, do we keep our clocks from going completely crazy?
Well, we solved it with this magic number, 24. Since it takes 24 hours to do one full spin, we just chop the planet up into 24 invisible slices. These slices are called time zones. By dividing the globe into 24 time zones, we guarantee that our clocks always match what the sun is doing up in the sky. Thanks to time zones, 9 a.m. is always morning time, and 9 p.m. is always nighttime, for sure, no matter where you live on the planet. Our clocks just adjust as the Earth spins through the sunlight.
All right, space detectives, it's time for a crazy what-if scenario. We know the Earth is spinning at 1,600 kilometers per hour. What would happen if our cosmic amusement park ride suddenly hit the emergency brakes and just completely stopped spinning?
Oh boy, it would be a total disaster. If the Earth stopped, everything not strapped down would just keep moving. We're talking winds blowing at over 1,000 miles per hour whipping across the land. And because the spinning force stopped, the oceans at the equator would suddenly rush away toward the North and South poles. But even weirder? Because we'd only be orbiting, not spinning, one side of the Earth would face the sun for 6 straight months of daytime, and the other side would freeze in 6 straight months of nighttime. One single day would literally last a whole year.
But hey, don't worry, take a deep breath. There are no giant space brakes. Thankfully, our cosmic amusement park ride is perfectly balanced, incredibly smooth, entirely safe, and is going to keep right on spinning for billions of years to come. So, I want to leave you with a challenge. Next time you're playing outside during the day, look up. If you manage to spot the pale moon hiding in the blue daytime sky, use your new space detective skills. Look at what side of the moon is lit up and see if you can figure out exactly where the sun is in the sky. It really makes you wonder, if our planet and moon are moving this incredibly fast in perfect harmony, what else in the vast universe is zooming around us right now, just waiting to be discovered? Thanks for joining me on this explainer. Keep looking up and stay curious.